The Periodic Table Trends by Jakob Margetta and Hecht. Brief history of the periodic table. Periodic law, the principle that certain properties of elements occur periodically when arranged by atomic number. This law is the origin for the periodic. The periodic table is an ordering of the chemical elements demonstrating the periodicity of chemical and physical properties. The periodic table is made of periods and groups. Period. A row of elements on the periodic table. Periods go horizontal. Group. A column of elements on the periodic table. Groups go vertical. Elements. A substance made out of one type of atom. An atom must have equal numbers of protons and neutrons. Currently, there are 118 elements known to scientists. "90 elements on the periodic table occur in nature. All other elements are man-made." Element symbol. This is either 1, 2, or 3 letters that are internationally known. Atomic number. The number of protons in an atom which defines the element. Atomic weight. The average mass of an element in atomic mass units. Russian scientist Dmitry Mendeleev is considered the father of the periodic table, but many other scientists contributed to the present model. Mendeleev created this table to organize the elements that had been discovered. The main difference between Mendeleev's original periodic table and the modern periodic table is the way it is arranged. Mendeleev arranged the elements in order of increasing atomic weight. The modern version of the periodic table is arranged by increasing atomic number. The first element to be discovered was phosphorus by Henning Brand in 1649. Metal, nonmetals, and metalloids. Metals. Metals. Red-colored elements left of the black line excluding hydrogen, which is a gas. All metals are solid except mercury, which is a liquid. Good conductors of heat that are malleable and ductile. Nonmetals. Nonmetals. Blue-colored elements right of the black line and hydrogen, the first element on the table. Brittle, non-malleable, or ductile. Poor conductors of heat and electricity. Metalloids. Metalloids. Yellow-colored elements that border the black line. Shiny or dull, ductile, and malleable. Blocks of elements. The blocks of elements consist of 4 orbitals. All elements can be categorized into one of these 4 orbitals. S block consists of 14 elements, which are listed below. S-block elements are in the s orbital. The s orbital is a spherical shaped and is occupied by a max of 2 electrons. P-block consists of 36 elements, which are listed below. P-block elements are in the p orbital. The p orbital is lobe-shaped and is occupied by a max of 6 electrons. D-block consists of 38 elements, which are listed below. Isn't that a lot, Jake?
Heck yeah.
D-block elements are in the d orbital. The d orbital is cloverleaf shaped and is occupied by a max of 10 electrons. F-block consists of 30 elements, which are listed below. F-block elements are in the f orbital. The f orbital has an unknown shape and is occupied by a max of 14 electrons. Atomic radius. As you go down a group, the atomic radius increases because of the size of the nucleus. New energy levels of electron clouds are added to the atom as you move down the group. As you go across a period left to right, the atomic radius decreases due to stronger attractive forces in atoms of opposite charges. Ionization energy. Ionization energy is the amount of energy needed to get rid of the outermost electron. The larger the level of ionization energy, it's harder to remove an electron. As you go down a group, the ionization energy decreases. It is easier to get rid of the outermost electrons from the atoms that are near bottoms of the table with many electrons. As you go across a period, ionization energy increases. The atoms do not want to give up an electron because they are close to becoming an octet. Ionic size. Ionic size decreases as it goes across a period, and increases as it goes down a group. Cation. What an atom becomes when it loses an electron. This is a positively charged ion. Anion. What an atom becomes when it gains an electron. This is a negatively charged ion. Electronegativity. Electronegativity is an atom's desire to grab another atom's electrons. The atoms in the 1A and 2A groups have low electronegativity levels. The atoms in groups 3A through 7A have high electronegativity levels. They want to gain more electrons to get to the octet, so every electron is a big deal. As you go across the period, the electronegativity increases. As you go down a group, electronegativity decreases. Interesting facts. Law of triads. The atomic weight of one element is equal to the mean of the atomic weights of the other two elements. Law of octaves. Elements with similar physical and chemical properties occur after each interval of 7 elements.
Weird science, elastic tubes and pots and pans, bits and pieces and